Hello everyone, this is P. Induja, working as an assistant professor in the Department of Chemical Engineering, Hindusthan College of Engineering and Technology. So in this session, we are going to see about the introduction to chemical engineering, thermodynamics. So what is thermodynamics and what are the scopes and limitations of thermodynamics and what are the types of systems and the laws of thermodynamics we are going to discuss in this session. So now, the science of thermodynamics which deals with energy and its transformation, and it tells us about the directions in which changes takes place in nature. It also determines the condition under which a proposed changes attains at a state of equilibrium. So that is a state in which no further changes is possible under the given conditions. So now we will see the definition of thermodynamics. So what is thermodynamics? So thermodynamics is a branch of science which concerned with heat and temperature and their relation to energy and work. So it is concerned only with heat and temperature and their relation is between energy and work. So it states that the behavior of these quantities is governed by the four laws of thermodynamics. So that is zeroth law, first law, second law and third law. So irrespective of the compositions or specific properties of the material or system in this question. So here there is a piston and there is a hot body and a cold body. So hot body is always greater than cold body. So that is TA is greater than TB. So next one is thermodynamic system. So a system is nothing but in thermodynamics a substances or a group of substances in which we have special interest is called as a system. So it is a part of the universe which is set apart for our special consideration. So it may be a reaction vessel or a distillation column or a heat engine we can say as an example. So here you can see the diagram which shows the system and the mass is getting in and mass is getting out and energy is getting in and energy is getting out. So there is a boundary. So that is a system boundary. So a system is nothing but a substances or a group of substances which we have a special interest is known as the system. So in a system, there is three types of system. So one is open system, another one is closed system, and third one is isolated system. So here, open system is nothing but it can exchange both energy and mass. And in closed system, which cannot transfer matters across the boundaries, are known as the closed system. And in isolated system, so neither energy nor matter can cross the boundaries of an isolated system. So these are the three types of systems. Next one is pure substances. Pure substances is which contains only one type of particle. So the substances does not usually occur in their pure form in nature. So in order to obtain pure substances, we refine raw materials. Some examples of pure substances are gold, aluminium and sugar. So uh, there is a mass which contains two particles. One is pure substances and another one is mixture. So pure substances is element and compound, and mixture is homogeneous mixture and heterogeneous mixture. So here homogeneous and heterogeneous mixtures are nothing but so homogeneous is the properties are the same throughout or properties vary smoothly without showing any surface of discontinuity. And in heterogeneous system which consists of two or more distinct homogeneous regions or phases. So in homogeneous there will be a one phase and heterogeneous there will be a two or more phases known as the homogeneous and heterogeneous system. Coming to the properties of system, property is defined as the characteristics of any system which is known as the pressure, temperature, volume, and mass. So it is defined to define the conditions of a given system. So the condition defined by such specification is called as the state of the system. So some are independent and some properties are dependent on other properties, like density is defined as the ratio of mass per unit volume. So since we know that mass and volume are properties, so there is the types of properties is, so the types of properties are one is intensive property and another one is extensive property. So intensive property is a property of a system which is dependent on the size of the system, such as temperature, pressure, and density. Uh, and also we can say it as specific volume as an example, or an intensive properties. Some intensive properties are derived from the extensive property by specifying the unit volume of the substances considered. So examples are specific volume, specific heat, and density. And extensive properties are property of the system which is dependent on the size as well as the extent of the system. So such as, for example, we can say it as mass uh, and volume are extensive properties. Yeah. So next one is laws of thermodynamics. So there are four types of laws. One is zeroth law, first law, second law, and third law. So zeroth law is nothing but when A is in equilibrium with body B and body B is in equilibrium with body C, then A and C are in also equilibrium, that is in thermal equilibrium. If they were brought into contact, there would be no net heat transfer will be occurred. So this is known as the zeroth law. And second is first law of thermodynamics. So first law of thermodynamics is the law of conservation of energy. So it says energy can neither be created nor be destroyed. So it is the versions of the law of conservation of energy adapted for thermodynamic system. So the law of conservation of energy states that the total energy of an isolated system is constant. So here you can see the energy before and energy after. So the next one is the second law of thermodynamics. So it is just the generalization of our experience with the spontaneous process and can be stated in a number of ways. So first one is heat cannot by itself passes from a cold body to a hot body. So here which states that the total entropy of an isolated system always increases over time or remain constant. So where the system is in steady state or which undergoes a reversible process. So in thermodynamics, second law of thermodynamics, so when it's steady state or in reversible process, so the isolated system always increases over time. So the increase in entropy accounts for the irreversibility of natural process and the asymmetry between future and the past. And the final one is third law of thermodynamics. So absolute zero cannot be reached. That is, who could always wants to be 0 degree Kelvin or minus 273 degrees Celsius. That is also equal to minus 459 degree Fahrenheit. So the third law states that regarding the properties of system in equilibrium at absolute zero temperature. So the entropy of a perfect crystal at absolute zero is exactly equal to the zero. So when it is in 0 Kelvin, 0 degree Kelvin, so the in degree Celsius also minus 273 degrees Celsius and in Fahrenheit minus 459 degree Fahrenheit in the third law of thermodynamics. Thank you.